So now you're hopefully convinced that message ordering is important. So let's discuss different types of broadcast ordering. And in this lecture, we will talk about two types of orders. Actually, the two types that we discussed in the previous slides, which are FIFO and causal. So we'll start from FIFO broadcast. So here's the specification of FIFO reliable broadcast. So we will say simply FIFO broadcast and we will omit reliable. So all types of broadcast that we're gonna consider are reliable. Okay, reliable in the sense that we discussed in the previous lecture, and I will clarify this whenever we talk about the specification, as you will see. Okay, so we have this module called FIFO reliable broadcast, and its instance is FRB. And as you might have expected, the interface is exactly the same as we had for the reliable broadcast. So there are two primitives. So one is request. So this is how we request to broadcast message M to all processes. And the indications are deliver message M from process SRC. So we have now 5 correctness properties, FRB1 to FRB5. So let's see what they are. Okay, so since we're talking about reliable broadcast, so these first 4 properties are basically exactly the same as we had for reliable broadcast. Okay, so those are validity, node application, node creation, and agreement, and they're exactly the same as the properties with the same name for reliable broadcast, RB1 to RB4. Okay, so this is just to guarantee basic reliability. So as we have said, this is just about reliability, but we still don't have any ordering. Okay. So the next property is what gives us ordering, and in this case, this is a FIFO ordering, and the property is called FIFO delivery. And this property basically says that if some process broadcasts message M1 before it broadcasts message M2, so this means that there is a FIFO order between M1 and M2, right? Then no process is allowed to deliver M2, so the second message that was sent by a sender, unless it has already delivered M1. Okay, so this is, I hope, quite intuitive to understand. Okay, so this is FIFO reliable broadcast. So when we discussed reliable broadcast, we also spoke about uniform reliable broadcast, or URB. And basically what happens is that reliability properties for broadcast are orthogonal to the ordering properties. And for that reason, we can actually define FIFO uniform reliable broadcast. And how we get FIFO uniform reliable broadcast, we basically just replace the first 4 properties of FIFO reliable broadcast with the corresponding uniform reliable broadcast properties, URB1 to URB4, and this way we get the uniformity. Okay, and then we just take the FIFO delivery property exactly as we defined it before. Okay, so uniform FIFO reliable broadcast has the same FIFO delivery property as the normal FIFO reliable broadcast. Okay, so this is the uniform FIFO broadcast. So let's see quickly how FIFO Broadcast can be implemented. And to implement FIFO Broadcast, so remember this, we are talking about FIFO Reliable Broadcast, we're gonna use the Reliable Broadcast component as a black box. Okay. So this is just an implementation of a regular Reliable Broadcast that we discussed in the previous lecture, or actually any implementation that satisfies the specification of Reliable Broadcast. So we put FIFO Reliable Broadcast layer right on top this layer, okay, and by using this layer as a black box, we get for free all the reliability properties of Reliable Broadcast. So this is how we basically obtain the first 4 properties. And then we need to add some extra smartness here so as to augment the basic reliability with the desirable ordering guarantees. So in this case, we're interested in FIFO order. Okay. So let's see briefly how that could be done. So this is not complicated. So the implementation works in the fail-silent model. And just to remind you, fail-silent model is the full asynchronous model, and it does not have any failure detectors. It only has a reliable point-to-point or links, or perfect point-to-point links. Okay. So, and it is implemented on top of Reliable Broadcast. So what we do, we probably would have expected something like that. So the messages which are broadcast by the same process are assigned consecutive sequence numbers, 1, 2, 3, and so forth, right? And then when the message is be delivered from this Reliable Broadcast layer to which we have access to, okay, so when message is be delivered, we make sure that all messages coming from the same sender, from the same process, are FIFO delivered in the order of their sequence numbers. Okay. And what is important is also without gaps. Okay. So, for example, if we got from a specific process, if we got message 1 and then message 5, right? So we can't deliver message 5 until we deliver all the messages in the middle, like 2, 3, and 4. Okay. So this is a simple implementation, and you can actually find it in algorithm 3.12 in the textbook, and it's called broadcast with sequence number. So there you can find further details of this algorithm. Now, to obtain a FIFO uniform broadcast, all we have to do is basically just replace reliable broadcast here with uniform reliable broadcast. Okay, and otherwise it's exactly the same implementation. So FIFO Reliable Broadcast is simple to specify and implement, and now let's look at a causal broadcast. So this is going to be a bit trickier.